Hello everyone, welcome to the Geeks4Geeks practice channel. Myself Kunal, and today we'll be solving our weekly contest 180. So the contest was consist of 4 problems, out of which our 2 problems was of easy level. Our first and second problems were easy, and our third problem was of medium level. And our fourth problem, we can say that it is somewhere from medium to hard level, right? So if you have basic knowledge of data structures and basic knowledge of programming, you will be able to understand our first 2 problems. And in third problem we will be using hashing, and in the fourth problem we will be using dynamic programming. So let's start with the first problem. So the name of our first problem is difference sum. So in the problem statement, we have given 2 complete binary tree, root 1 and root 2. A binary tree is complete if every level except possibly the last is completely filled and all nodes are as far left as possible. Your task is to find the sum of the absolute difference between the values of corresponding nodes in the 2 trees. If one of the nodes is null, consider the value of the node as 0. Right? So we have given 2 binary trees, and it is said that they are complete binary trees. So what does this mean by that they are complete binary trees? So by complete binary tree, it meant that if the height of our binary tree is 3, so the nodes at first and second level will be complete, and at third level it is not necessary that whether they will be complete or not. And similarly, if the height of a binary tree is 4, then the nodes at our third level, up to our third level, will be complete, and at our fourth level it is not necessary whether they will be complete or not. So in this problem we have to find the sum of the absolute differences between the values of corresponding nodes, right? So like the difference between this root node and this root node, and difference between our left of root node to the left of root node, right of root node to the right of root node, right? We will be finding the difference between the corresponding nodes. So let's understand with the help of an example. So here's our example. So our first binary tree is 1, 2, 3, and 4, and the second binary tree is 2, 7, 1, 3, 5. So what will be the sum of differences between the corresponding nodes? So by differences here we are talking about the absolute difference. So the sum of root nodes, so the difference of root nodes is 2 minus 1, which is 1, and 2 and 7 we have now. So 7 minus 2 equals to 5, 3 minus 1 equals to 2, and 4 minus 3, which is 1, and here we have 5. And if a root is null here, like here the right of our this node 2 is null, so we will be taking 0. So 0 minus 5, which will give us 5, right? So we have found the difference of each consecutive nodes. Now we will add them and find the sum. So 1 plus 5, 6, 6 plus 2, 8, now 9, 9 plus 5, 14. So we will get our sum of the differences between consecutive nodes as 14. So for this, we will be using recursion to traverse our binary trees, and in each step we will be finding the difference of the current nodes, and we will be adding the difference of their next left and next right. So what we will be doing, we will be finding the difference of current, and we will be adding the difference of left and plus difference of right. So here we can have 4 conditions. Those 4 conditions can be, here we have our root 1 and root 2. So these 4 conditions can be our root 1 exists and root 2 also exists, and second condition can be our root 1 exists and root 2 does not exist. Third condition, our root 2 does not exist but root 1 exists, and in fourth condition our both root doesn't exist. If we somewhere found this that are none of the root exists, so we will come out of our function, we will return. And in this case, we will access both right and left of both the nodes. And in this condition, we will access right and left of root 1. And as for the root 2, as it is null, we will take its left and right as 0. And in this case, we will similarly access the right and left of root 2. And in this case, we will return. So let's understand the code. So this is our code for this problem. So here what we are doing, we have 4 conditions, and initially we have a if condition, if root 1 and root 2. So first condition, if both the root exists. If both the root exists, we are returning a difference of current nodes, and plus we are calling left of both the nodes, right? We are using recursion to call the left of both the nodes, and it will be giving us difference between these nodes. And we are also adding the difference between the right nodes, right? And it will be calling, like, we have these nodes, we have these trees, we have calling the right, and it will further calling the left of right and the right of right until our both nodes become null, right? Similarly, we have in the second condition, if root 1 exists and root 2 doesn't exist, we are returning our root 1 data, because it will be root 1 data minus 0, so it is not necessary to write it. And difference sum root 1 left comma root 2. So as root 2 is null, we can't access its left, so we are passing root 2 as it is. And similarly for the right. And in third condition, when our root 1 doesn't exist but root 2 exists, so we are returning the root 2 data plus root 1 as it is, because it is null, and we are accessing left and right of our root 2. And lastly, if our both the roots are null, then this else condition will be occurred, and in this else condition we are returning 0, because if both the roots are null, they both have value 0 and the difference will be 0, right? So this is our solution to the first problem. I hope you all understood it. So now let's look at the problem 3. So the name of the third problem is unique array, and the problem statement says that we have given an array of length n, and we have to do following operations on the array at most once. So what we have to do, basically, we have given an array and we have to make all the elements of the array distinct, and we can remove a subarray from the array, and we have to find the minimum size of the subarray that needs to be removed from our current array, which makes all the elements of our array distinct, right? Let's understand it with the help of an example. So here in this example, we have given an array 1 2 3 1 2, and the size of the array is 5. So here we have 1 is repeating twice and 2 is also occurring twice. So either we can remove this subarray or this subarray, right? If we remove this subarray, it will make all the elements of this array distinct. And what is the size of the subarray that we have removed? It is 2. So we will return 2 from our function, right? So let's understand it more with the help of one more example. Here we have another example. So here we have 1 2 3 1 2 2 1 8. So to remove the subarray, from where we can remove, here we have 1 is occurring multiple times and 2 is also occurring thrice, and other number 3 and 8 are distinct. So we have to remove 1 and 2 occurrence of 1 and 2. So if we remove this subarray, it will make it easy, it will make it distinct, right? It will make it 1 2 3 and 8, right? So It can be either from this end, or either in the middle. So the subarray that needs to be removed can be anywhere in the array, but it will be consecutive as it is a subarray. So how can we do this? So firstly, we will be creating a map. And in the map, we will be storing all the elements with their respective indexes. Like here we have 0, 1, 2, 3, 4, 5, 6, 7, and we will be checking all the unique elements that we have from the start and also from the end, right? Because there can be only three cases. Either the subarray that we have starts from the 0, or it ends at 7, or it starts from somewhere in middle, or ends somewhere in middle, right? So 0 to somewhere I, and I to somewhere 7, or somewhere I to j, right? So what we will be doing, we will be storing all the elements with their respective indexes in our map. So initially we will be running two loops, one from 0 to n and other will be from n minus 1 to 0, right? So what we will be doing, we will be storing all the elements with their indexes, and whenever we found a repeating element, we will be storing its index before it, right? Here we have a repeating element 1. 1 has already occurred before, so we will be storing this index 2, as 0 to 2 can be our final array, right? As all the elements we have here are distinct because we are traversing up to our first repetition. And after that, we will be doing similar thing. We will be traversing our array from the back, and after traversing from the back, we will be storing this in the similar map. Like here in the map, currently I have 1, 0, 2, 1, and 3, 2. And now when I cut this one, I'll come out of this loop, and now we will traverse from the back, and while traversing from the back, we will be storing the element and their respective indexes. Now we will store 8 at 7, and now I have 1, but 1 has already occurred previously, so 1 can be element that needs to be removed. So as we have taken all the distinct elements from the back, we will be ignoring this one, right? So what we will be doing, we will, like, this index is id, and we will be taking all the elements that we have until we reach this one. So we will be removing this one from our final array, right? And now we have 2, has 2 occurred previously, as we have ignored this whole array because we are finding distinct elements from the back. We can only consider one subarray, so 2 has no occurrence. And here we have another 2, it has occurred previously. So while doing this, we will be adding our length of this and length of all the distinct elements that we have found. Like here we have 3, and here we have 1. 3 plus 1, right? This 8 is distinct and this 3 were distinct. Initially we had only 3, right? After this, as we have occurred 1, so we will ignore this whole array, right? Because of the 1. As if we had 3, we will be ignoring only this 3, but as we have 1, we have to ignore the whole subarray, right? So here we have 0, and here we have 2 because it is currently 1, and here we have 2 now. So here we have 0 plus 3, and here we have 2 again, so 2 repeats again, so we can't consider this 2. So the maximum we can find is this. So among these, 1 will be our expected result. So we have 3 plus 1, 0 plus 2, 0 plus 3. So the maximum among them is 3 plus 1, which is 4. Now what we will be doing, we will be returning our n minus current answer, right? Because what we have found, we have found all the distinct elements that we have, right? By removing the elements that are occurring multiple times, by removing that subarray, this answer will be consisting all the distinct elements, and we have to return the size of the subarray with multiple occurring, right? So we will be returning n minus answer. It will be our final answer. So let's understand the code for this solution. So here we have the code. So what we have done, initially we have created a map, and we have an answer, and we have created an id variable. In this id variable, we will be storing the occurrence of our first repetition, the index of our first repetition, right? So we have running a loop from left to right, and we are storing all the elements and with their indexes. And if we found that any element has appeared before, so we are breaking out of the loop. So this index will be storing our all the distinct elements up to 0 to our distinct id. Up to 0 to id, all the elements will be distinct, right? Because we haven't updated this index when we found its next occurrence, right? So now we have this answer. So 0 to id, this can be our desired answer. So we have storing this in our answer, right? So like id has index 2 and it is 0. So what will be the length of this subarray? It will be 2 plus 1, which will be 3. Here we are running a for loop from backwards, right? We are traversing our array from the back now, and we are checking whether our current element has appeared before or not. If it is not appear, we are updating it in a map, and we are also in each step we are also updating our answer. So what is this? So we have our answer, right? We are finding the maximum among answer, and id plus 1 will give our all the unique elements that we have from the 0 to start, right? And this n minus I, this n minus I will give us from all the unique elements from the end, right? Because I is pointing to my current element, which will be unique, right? So we are storing, we are checking which is maximum, our previous answer, or distinct elements from start and distinct elements from the end. And we have this other condition, else if mp of array of I is less than I. So if the previous occurring of my current element has occurred before its current index, right? Like if we had 1 2 3 1 2 2 1 8, right? If we have this one and the previous occurring of this one is less than the current index of this current one, right? As its current index will be, its index is 0, its index is 6, 0 1 2 3 4 5 6, right? So when we found this, we will be doing what? We are decrementing our IT until it becomes equal to IDX. So at IDX, we will be storing the index of our first occurrence, right? MP of array of I, it will be this 0, the index of our first occurrence of element. And IDX, we stored the IDX at 1 less than the first repetition. It is standing at that 2. So we won't be taking this subarray as it has 1 in it. So we need to ignore 1. Now we have this else condition. If the repetition that we have is greater than the previous repetition, than the previous occurrence, right? If the previous occurrence has greater index than our current occurrence, what we will be doing, we will be breaking out of the loop, as we have already found the subarray that needs to be deleted, right? So here After doing this, what we will doing after this one, we will have this ANS as 4 and this ID plus 1, this ID will become 0, it will be 1, and here this n minus I will be n minus 2, it will be 8 minus, so this index is 7 6, will be 7 minus 6, will be, sorry, 8 minus 6, right? So we will be keep doing it until we found a repetition which has occurred previously in the same subarray, right? And after that our else condition will hit and we will break out of the statement, and our answer will be containing all the distinct elements from the start and from the end, and we will be returning n minus answer, which will be the length of all the repetitive element subarray that we need to delete. So this was our question 3. So now let's start the problem 4. So the name of the problem 4 is minimum travel cost. So what's the problem statement? So in the problem, we have given a 2D array of size n into m. So we will be having a matrix of size n into m, and in that our n will be representing some towns, and each town will be having some m roads. M roads will be represented by some elements, like here I have 1 2 3 4 5 6. So right, so I have 2 towns and each town is having 3 roads, and this represents the cost of each road, right? So what does it say? The jth road of town I is connected to the kth road of town I plus 1 if GCD of town ij comma town I plus 1 of k is greater than 1. So the roads of this town are connected to this town only if they have a greatest common divisor which is greater than 1, right? Like if I take this 1 here and this 5 here, what will be the GCD of 1 and 5? It will be 1, but so it is not greater than 1, right? But if I take here this 2 and this 4, so what will be the GCD of this 2 and this 4? It will be 2, and yes, it is greater than 1. So it makes a passage. So these roads, I can say these roads are connected with each other. Similarly, I can say this 2 is connected with 6 and this 6 is connected with this 3. As what will be the GCD of 3 and 6? It will be 3 and it is greater than 1, right? So what I have to find? Geek lives in town 1 and wants to find the minimum cost he has to pay to reach other n minus 1 towns. Help him to find the minimum cost. If it is not possible to reach any town, the cost is minus 1. So what I have to do, like I have a person standing at town 0, right, at the first town, and he wants to reach to the town, to the last town, and we have to provide the cost that will be required to go to each town, right? So if it is impossible to reach any town, like we have something here 1 8 7, and we have something like here 3 5 and 9, so none of them has a GCD of greater than 1. So yes, so the cost to reach this town will be minus 1, so as we can't reach this town, and cost to reach this town will also become minus 1 as we can't reach this town because this town is inaccessible, so we can't reach this town too. So what we will be doing, we will be returning, you need to return an array of size n minus 1. So if I have n towns, I'll be returning an array of size n minus 1. If I have, for this we have 1 2 3 4 5 6 7 8 9, and I'll be taking an array of size 2, which will be giving us minimum cost to reach ith plus 1 town. So I'll be having 2 elements in my array. So in that I'll be storing the cost to reach this second town and this third town. As my geek is already standing at town 1, so I don't need to find the cost of the town 1, as it will always be 0 because it is our starting point, right? And as you can see, this 2 is connected to this 4 and this 4 is connected to this 8. So like if I have something like 9, 16, 52 here, so this 8 will be connected to this 16. So it will be forming a network with the connected roads, right? And I can't jump to other road if I go from 2 to this 4. So I have to find a way from this 4. I can't move to other roads of this town. And to form a network, there's a one common thing. Each road will be having a common GCD, right? Like here in 2, 4, 8, 16, and like here I have something like 32, and it is something like 6. So they will be having a GCD which will be common and it will be greater than 1, right? The GCD will always be greater than 1. Like in this case, it is 2. So this example is clear. Let's understand it with one more example. Like here we have this road, and here we have 3 towns, and in this table we have 3 roads. Each town is having 3 roads. So let's see which will connect. So this 6 will connect to this 6 as they have a GCD of 6, and this 3 will connect to this 6, 3 and 6, 6 and 6, and this 8 and 4, right? So what I can have, I can go from this 4, go from this 6, from this 8 and this 3. If I use this 6, I can go to this 6, which will be costing me 6 units to go to this next. This 6 is connected to this 9, and so what will be the cost to reach to this last town? It will be, as it costed me 6, it will cost me 6 more. It will be 6 plus 6, 12, and from this 8 I'll be reaching to this 4. It will be similarly 8 plus 4, which is 12, and here I have this 4, here I have this 3, and from this 3 I'll be reaching to this 6, and after that I can reach to this town. As this 6 is connected to this 9, GCD of 6 and 9 is what? It is 3, which is greater than 1. So with the help of this 6, I'll be using this 6 as the next root. So it will be 3 plus 6, which we can write as 9. So these are the paths that will be formed, and we will be taking the shortest path, the one with the smallest amount of money spent. It is as this one. So the answer for this will be 3, 9, right? So how can I approach this question? Firstly, I'll be finding all the factors for all the prime factors for all the numbers I have. Like I'll find the maximum number here. Here it is 9, and I'll find all the prime factors from 1 to 9 for all the numbers. And after that, we will be creating an array which will be storing minimum cost to reach each road having prime factor, having that particular prime factor. Like I have this, like I won't be taking 1, I will be taking 2, and I'll be taking 3, and I'll be taking 5, 7, right? Similarly, and I'll be creating one array. Let's call that array MP. And firstly, what we will do, we will be finding all the prime factors, and we will be storing that in an array. Let's call it prime factors. It will be having all the prime factors from 2 to the maximum element of this matrix, and In the second array, we will be storing our minimum cost to reach each road which has this particular prime factor. MP of I will be having a minimum cost, and I is representing a prime factor, right? Like for this 2, it will be having the minimum cost of the road which is having a prime factor as 2, and we will be using dynamic programming to solve this question. So we will also be creating a 2D DP array, 2D DP. Let's call it something like dp of I of j, and it will be storing the minimum cost to reach each road from a particular town, right? Each road of the town, like I have a 2D array here, and it has 1 2 3 4 5 6 7 8 9. So, and I have this dp array here. This is like my towns array, and I have this dp array. I have I j k l m n o p q. So this k will be, this n will be representing the cost to reach this 6, and this m will be representing the cost to reach this 5, and this l will be representing the cost to reach this 4. So dp of I of j will be representing the cost to reach the towns of I of j, right? So it will be storing minimum cost required to reach on that road at that position in our towns table, and we will be finding the cost of each road for every town, right? We will be finding the cost of each road for every town, and what we will be doing now, we have like an MP which is consisting all the minimum cost for the roads which are having that particular prime factor, and we will be having a prime factor array with the help of which we will be building our MP array, and we will be having a 2D DP array of size n into m, which will be containing all the elements, all the cost for respective roads, right? And initially, initially the zeroth row, the zeroth index will be containing 0 0 0, because the cost to reach at the first row will be 0, as my geek is already standing there. And for the second row, we will be taking the help of this MP array, with the help of which we will be finding our GCD. And like similarly here, it will be giving me a connection, like this 4 is connecting to this 8, and this 6 is also connected to this 8 because of the common GCD, which is 2, right? So let's understand the solution. Here's the solution. So firstly, we have created a find factors function. So what we have done in this find factors function, we have initially created a vector, and in that vector we will be checking whether this number is divisible by 2 or not, until it becomes not divisible by 2, because we need to find all the prime factors. So to find the prime factors, we will be dividing it by 2 until it can't be divided by 2 further, right? And now in the next for loop, we will be iterating it from 3, right? Because 3 is a prime number, and we will be incrementing it by 2 to check for all the prime numbers we have. And we have checking for the square root of n, right? Because like we have 25, so we will be checking up to 5, because 5 into 5 is 25. There's no way it can be divisible by 6. So we have done the similar thing. We are checking whether it is divisible by I. If it is divisible by I, we are dividing it by I, and we are checking it again. Now at the end, we will have some n left. We will have an n left, which will be checking if it is greater than 2. If the number we have left after finding all the factors is greater than 2, then that number is a prime factor in itself. Like we have left some 13, right? We can't find any number which will be divisible by 13. So that because 13 is a prime number in itself, so we will be pushing that number in our final array. That's how we will be finding our factors. We might have used the GCD function, but in the further implementation of our program, it would be making things more complicated. So that's how we have implemented our find factors function. Let's jump to the main code now. This is our main code. So initially we have this int n, int m, and a vector town. This is the number of towns, this is the number of roads, and we have created the mx. What are we storing in the mx? In this mx, we will be storing our maximum element equals to mx, because we will be find all the prime factors up to this mx, right? We don't need to find more prime factors which are greater than the our maximum element, because there won't be any need of that. So we are finding the maximum element, and we have called our this prime factors function, which we have created above. Sorry, we have creating a prime factors array, and in that we will be calling our find factors function, which we have created above, and that we are storing all the prime factors from 2 to mx. And now we have created an array which we have named as mp, and in this mp we are creating it up to mx plus 1. It will be the size of mp, and we will be storing originally 1e5, which is a 1e15, which is a very big number, so that because it will be containing the minimum cost, so initially we are taking it as 1e15 because we don't know the cost, so we are putting it as a very big number. So now we are creating a dp table, so the size of the dp table will be n plus 1, and in that we will be storing our 1e15, right? Because we don't know what will be the cost to reach each element. But in the next step, what we are doing, we are storing 0 at the 0th position of our dp, right? Because it will be containing, like, the size of our dp is n plus 1 into m, right? It will be n plus 1 into m, because we need to make it one size more, right? And for the first row we are putting all at 0 because our geek is already standing there, so the cost will be 0. And now we are running a loop from 1 to n, and in that loop we have 3 loops. So in the first loop, what we are doing, we are checking for each prime factor we have in that at that particular element, right? So we are accessing our prime factors array, which is containing all the prime factors, and like prime towns of I minus 1 of j, like it points at a particular road which has 9, so it will be containing all the prime factors of 9, which will be like 3. And if I have something like this 36, it will be containing all the prime factors of 36, which will include 2, 3, and any other. So int j equals, so now in the next, so what I have done here, I am putting those values in my mp array. In the mp array, I'll be finding the minimum cost, which is mp of it, and town of I minus 1 of j, which represents the current cost. Town of I minus 1 of j represents the current cost. It represents the current cost of our road, and dp of I minus 1 of j This represents the cost that is taken to reach that particular I minus 1 comma j road, right? So after that, our MP of IT will be storing the minimum cost that will be taken by that particular prime factor. Now we have this next for loop. In this next for loop, we are traversing over our prime factor array similarly, and in that we are updating our dp of I of j. Now dp of I of j and mp of it will be containing the minimum cost that was required to reach that particular road, right? And I'll be comparing it with the element that was previously present in my dp and our mp of it, and I'll be storing minimum among them in my dp. And in the third loop, after each loop, as my mp array is a 1d array, so I'll be changing it to 1e15 so that my old values will get updated, so it won't take old values in the next iteration. And I'll be doing this for all the elements, right? Because I have called I every place here, so all the elements will be accessed with the help of these two loops, right? And after that, my dp will be having all the required cost for each element. Now in the last loop, what I'm doing, I have created an answer array, and in the answer array I have created a minimum, and I'll be finding the minimum element from my dp. And if my minimum element is equal to 115, means there is no way to reach any road, any particular road, right? Like n minus 1 road, n minus 2 road, any road there, if it is equals to 1e15, if my minimum element is 1e15, then I can't reach to that particular road, so I'll be pushing -1 in that case, and else I'll be pushing that particular number which is minimum, right? So I'm doing this n times, so I'll be doing this for each town, and after doing that, I'm pushing it in the answer array. After finding the minimum element in each row of the dp, I'll be finding the minimum element from each row, and minimum element of each row will be containing the minimum cost that was taken to find that particular element. And after that, I'm pushing that in my answer array, and now I'm returning my answer array, so it will be my final answer. So this was the last question of our weekly contest 180. I hope you all understood all the problems. If you have any doubt, feel free to ask in the comment section. Thank you for watching, everyone.